Okay, theorem 9.1.1 in this section will help us count how many integers there are in a certain list. So for example, think of the list 5 through 12. So let me write it down: 5, 6, 7, 8 through 12. So suppose I want to know how many numbers there are in this list. Well, I could go and count, 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 in total. So that's one way to do it. The other option to do it is to think of the first number being called the number m. So this guy is going to be called m. Think of the last number as being the number n, and just basically do the following: n minus m plus 1. Okay, so n is 12 minus m, which is 5, plus 1. So that's going to be 8. So it counts how many numbers there are in a list. So this is a pretty cool theorem, and we're going to use it to do a lot of counting. So I highly recommend that you try to memorize it. Okay, now why is it 8, not 7? The reason why it's 8, not 7 is because it's including the start and the end in the amount. So we're including 5 and 12, not just 6, 7, 8, 9, 10, and 11 and 12. So let's see how we can use this to do something a little bit more interesting. So for example, how many 3-digit numbers are there from 100 to 999 that are divisible by 5? Okay, just as a reminder, to be divisible by 5, you have to end with a 0 or a 5. So like for example, 10 can be divided by 5 because it ends with a 0. 15 can be divided by 5 because it ends with a 5. Now if I told you what about 14? You're going to say it does not divide by 5 because it does not end with a 5 or a 0. Okay, so I'm going to make a list, basically 100, 101, 102, 103, all the way to 999. So 104, 105, and so on and so forth, all the way, let's say, to 995, 996, 999, and so on. Okay, so 997, 998, and 999. So this is my list, basically. What I'm going to do at this point is select the numbers from the list that can be divided by 5. And I know what they look like. They have to end with a 0 or end with a 5. So 100, definitely going to be divisible by 5. The 105 definitely can because it ends with a 5. What about the, there's certain numbers in between, like the 110, the 115, and so on. But from these ones that I wrote, the last one is going to be the 995. That's the last one that can be divided by 5, nothing else. Okay. By the way, 100 is 5 times 20. The 105 is 5 times 21. Okay, so you can test it out. You can use your calculator to figure that out. What about the 995? 5 times what? Well, using a calculator, we'll find out that it's 199. Okay. So what I've done so far is this. I started off with a list that contained the numbers from 100 to 999 inclusive, and I've turned it into a second list that goes 5 times 20, 5 times 21, 5 times 22, which is 110, and so on and so forth, all the way to 500, 5 times 199. Okay, so my list basically is 5 times 20, 5 times 21, 5 times, and so on and so forth. So in other terms, my new list is pretty much 20, 21, 22, all the way to 199. I'm just ignoring the 5 because I know that 5 times 20 will be 100, 5 times 21 will be 105, and so on. Okay, and so how many numbers are in this list? If I can figure out how many numbers there are in the list here, I'll figure out how many original numbers can be divisible by 5. Okay, so at this point, I'm going to call the first one m, and I'm going to call the last one n. So there are 199 minus 20 plus 1, which is 180, 3-digit numbers that can be divided by 5. 3-digit numbers. So the solution that we're looking for is pretty much 180. Okay. So how many numbers in the same list from 100 to 999 can be divided by 6? It's going to be a little bit more difficult to count these ones, but I'm going to make the same kind of list, 100 to 9999. And what I'm going to do next is select all the numbers that can be divided by 6. And I'm going to do that by trial and error. So I'm going to put 100 into my calculator, divided by 6. It doesn't work. I'm going to try 101, 102. 102 seems to be the one that works. So 102 is the first number that works. By the way, 6 times 51 is gonna be 102. And the next number is gonna be 108 divided by 6 is gonna be, again, something that works. Okay, I'm sorry, I apologize. I said 51. It's not 51. It's actually 17. And 108 divided by 6 is going to be 18. And so on. The last one that works in this list is going to be the 996. And when you divide it by 6, that one is going to be 6 times 166. Okay, so again, I've taken my old list and I've made it into a brand new list with these pink numbers. And since they all have 6 in common, I'm going to pretty much ignore it. So my new list is going to be the list containing 17, 18, 19, all the way to 166. And so how many are there in this list? How many numbers? In this case, there are 150 three-digit numbers that can be divided by 6. Okay, so finally, the question is, what's the probability that a chosen three-digit number can be divided by 6? So what's the probability that we get one of these 151? So what's the probability that a chosen random number, three-digit number, can be divided by 6? And well, to do this problem, we know that the numerator has to be 150 because there are 150 three-digit integers that can be divided by 6. And we would like to know what's the total number of integers. So let's find out what the total is. The total is going to be pretty much 999 minus 100 plus 1, which is basically 900 integers. That's how many three-digit integers there are, basically. So 150 divided by 900. And again, I would like it as a percentage with 2 decimal places. So that's a 16.67% chance.